Hello. So first of all, I wanted to apologize for the apple. Who would have thought something like that would really crash in? But anyway, seriously, I mean, take one for the road. They're there, and we don't want to waste them. Yeah. I'm sorry. Of course. Yeah. Yes. I'm struggling with the. Yeah, just a second. Ah, great. Okay, so we're back. So, okay, great. Yeah, so my name is Richard Brosey. I work at Yara. Yara is a chemical company, fertilizer. They produce fertilizer since over 100 years, so they're definitely not a startup. They also have a lot of sites which do R&D and do a lot of experiments with plants. And as Marco already explained in his talk, that is kind of a difficult thing to do because in all of the different areas of the world, plants behave differently, and then there is a change from one crop to another and so on. And recently Yara has ventured out into the digital branch and is trying to pull all this knowledge that the agronomists over in this company have acquired over the last 20 years or so, to pull this into digital products. And I'll give you a short overview over that after motivation. It's actually, I mean, the problem is that food will be a huge problem in the future. If you look at this graph and we see that in 1960 there were only like 3 billion people in the world, and now we are over more than double of that. And in the near future it will increase even further drastically. What happens after that is still not really sure, but the trend is just going up. If we have a look at how we actually use all this habitable land that we have on this earth, there is no more than that. We already use 50% of that just for agriculture. And if we want to feed more and more people, we either could chop down the rest of the forest there is, that's actually going on at the moment. We could plant in the desert, but that's with the current political situation not very likely. So we probably have to make a much more efficient use of how we're doing things currently. I wanted to show you like one picture which I find very shocking. So this is like the south of America, sorry, from space. You can see the contours here, and you might also spot the JPEG artifact, so to say, directly over the Google thing and at the top over there. These are actually not artifacts, but if you zoom in, you'll see that these are gigantic fields which have just been chopped into the forest. And just look at the scale down below, it's 50 kilometers. I mean, 50 kilometers for one field, even more. That's really a problem. And if this keeps going in the next 20, 30 years, we don't have any forests left, and we run into a lot of different problems and also waste a lot of resources there. So the thing is, how to grow the food more sustainable and make do with what we are actually currently using. And to this end, Yara is now undergoing a digital transformation, which is not an easy task in an already established company, which is very traditional. And they created several hubs around the world, one of them in Berlin, that's where I work. And they already now delivered several products. One of them is @Farm, that is using satellite image analysis to suggest to the farmer a certain variation of how to give the fertilizer within one field. So if you just look at the right under the generate application map, there is like this one field, and you see some bold areas and some very greenish areas. And you want to vary the amount of fertilizer that is spread out by the tractor on the go. And this app is doing this in a way that you can, as a farmer, download the application map, upload it on the tractor. Tractors nowadays are pretty far advanced. In general, farmers are, as they are leading huge businesses, oftentimes they are very much at the cutting edge of agro-tech. So the tractor can understand this while driving, and GPS monitoring, it can actually just vary on the spot the amount of fertilizer that is added. That's the same with pest control and so on. And this product is actually already making a difference, even though it has been released this year. We're already covering like over 800,000 hectares with this, so that's, I mean, on a global scale that is still very small, but we're improving there. So a similar product, and this is the one I focus on today, is how to irrigate more precisely, and especially very valuable tree crops. If you have, as a farmer, invested into a large orchard and have planted these trees, first of all, you have to wait for a certain time until you can reap any benefits of that. And then you want to do this over several years, and you really don't want your plants to die. So you need to irrigate these fields. And if something like, for instance, in California, the climate is increasingly harsh and there are increasing amounts of droughts over the last years, the trend is clear. I mean, they will transform into a desert. This makes irrigation very necessary, and so in order to not waste any water, and this actually has come already into the public media, that there is actually no more water left anymore, and we are drafting on groundwater which is actually not refilling at the same speed, not even close. So water reservoirs which are below ground in like solid rock, they refill over a time scale of 1,000 years or so, a little bit. But we are pulling out water every year to pour on our trees and other crops, and we are actually wasting this. So to reduce the amount of water that is needed is actually very necessary. And that's where I work in adaptive irrigation and drought management. So the idea is to combine different factors, like weather data, of course. I mean, when it's hot, you need to water the plants more than if it's not hot. But also like field configurations, also different irrigation scenarios, because sometimes you want the plants to suffer. For instance, olive trees, when the fruits are already like dark and ripe, you don't want to give the trees any water anymore, because you want to have olives which are full of oil and not full of water. But usually you want to keep them at a certain satisfying level. And for this, you need, if you want to manage this in a digital way, you need to relate the state of the plant to some abstract water status, which you can then regulate over time adaptively. So, for instance, here it would be optimal to have it somewhere in the middle. To the left, we would waste water. To the right, we would risk the plant dying at a certain point. And then put this into the pipeline to then in the end give some recommendations or even add it to a certain automatic irrigation system. And of course, this problem is not new, and a lot of scientists, agronomists have already created ideas and models and rules about this, and they themselves can identify plants or can identify the water status for their plants very easily. But how can we translate this into a computer model? And we need to somehow pull the knowledge out of them to really then feed this into a certain model. And the first step is to equip these orchards with sensors which capture different parameters like the moisture of the soil, the temperature, the rainfall, but also how sturdy the leaves themselves are. So we add some pressure sensors to some of the leaves on some of the trees, and we can monitor over time whether the leaves hang down or whether they are really sturdy. And my talk is called Using R in a Mid-Sized Data Scenario. So what does this mean? So our data is not big data. It is fairly large data, but it still fits into a SQL database where we just continuously feed new readings over time with our IoT setup. And then on the other hand, why do we use R? Well, a lot of people in the company, in the agronomic sector in general, they already tend to speak R to a certain degree. There is here and there some body of code already existing, and to include this in our routines, at least at the start, has proven very beneficial to the whole team idea and the progress. To then also some of the agronomists, they start with using R a little bit and then they grow into their role, so you kind of educate those people in that regard. That's actually a very good thing. For this specific problem at hand, we have tried several different things, also these undefined Excel sheets and so on, which is really not a good idea. And in fact, we have then settled down to use a Shiny, that is a package for R in RStudio, which allows for the creation of rather simple internal web applications from R. So you get all the information which someone who does interact with it directly into the R session and so on, which is rather convenient because then everything is in one language. And there the agronomists can add their comments, their marks and labels and evaluates, and we of course take everything of that out and put it into a SQL database so we can keep it for later and build different data sets from that. Yeah, so we combine this with the curated raw data, of course, and want to build a model out of this. And here I want to just mention the concept that Wes brought up this morning, the interoperability with other programming languages. And to that regard, R and RStudio especially has made some very good progress in the past. So there is the Reticulate package, which kind of combines the R and Python engines in a certain way that at least some of the data sets can be memory mapped between them, and you can then easily switch back and forth between the two. I will give you later a short example of this. It's actually really easy to use. And it also facilitates transition, like an organic transition from R into Python if you want to go more into that direction. So this of course opens up Keras and TensorFlow and everything like that, and it's very straightforward to just then take the different models for different tree crops and so on and different conditions and just put them, push them into TensorFlow, which of course then in the end allows, as we still have mid-sized data sets, for a nice online serving environment which still uses the R and TensorFlow combination to generate this artificial water status, which then at later steps can be combined with the other factors I mentioned to generate recommendation. The question is, we use R, so there are a lot of packages from third-party providers and so on, and to really make this the R environment reproducible and to write the code in a way that it doesn't behave subtly different in a different environment, and also to have it portable and scalable, horizontally scalable, so we can just duplicate these environments. We of course use Docker for this, and there is a very nice project which already wraps R together with RStudio and some other packages based on daily snapshots from the complete R package archive, and then you can just define which kind of version you want to use, which makes it very easy for the development process to really define at what point do you want to make a transition to a new version of a package, and then you can control it, just update this. So we can use it in our mid-sized data set for both development and production So you would just specify your version number there, and you can just use then RStudio very conveniently, similar to Jupyter, from your browser, which is very convenient. Although you need to keep in mind that, like, for instance, this password is just an environment variable, so everyone who has root access to the host machine can read it in clear text. And also, if you want to go outside, there is no HTTPS coming with it, so use a proxy for that. Yeah, and the next step, you of course want to do the same for Python as well. So you want to have R in a defined version with all of their packages, and you want to use Python with all of their packages also in a defined version. And there is the PyEnv project on GitHub, which nicely achieves that. And there even is a very convenient, straightforward implementation of using this and adding it up on the Docker container. It's basically just taking the Docker tidyverse and adding the PyEnv, cloning the PyEnv on top. So some other things, if you, and this is very convenient, I suggest you do this, develop all your packages within this environment. You want to persist your data, of course, and you want to add a volume into this. And one thing I struggled once with it is that the user ID must match with the host system. That is just something I wanted to mention. Yeah, you can just follow this link. Another thing that came up yesterday once is the question of how to integrate Microsoft SQL databases. And in the past, this was not so very easy to get it to run with different Linux environments, but nowadays Microsoft is doing really an effort to get this going, and installing the ODBC drivers for Microsoft ODBCs. Yeah, it's a bit wordy, but it's still doable, and you can just add this as another Docker file at the end and build this. So, next question, how do you handle secrets? And for all of the interactive sessions, there are two packages which allow for asking for a password in a secure, rather secure manner. And of course, again, if you want to do something non-interactive, you could use Kubernetes for handling those secrets. This is also very straightforward. Now I would like to show you some short things or anecdotes which I found very useful for my progress. One is that RStudio offers, if you want to communicate with other people on the team, especially those which are not really programmers or data scientists, but more like agronomists and biologists, you want to supply them very often with explicit plots and information about what you're actually doing, and you are like running around in circles, asking them, yeah, like this, and then discussing different ideas. R offers a lot of notebooky style things, but I personally don't find them very useful because you need to copy the code into different elements and so on, but it's also now possible to just write some code, clean it up a little, press this button, and then it will generate a very nice report out of that. And in this example, I show you the usage of this reticulate package. So this is an R environment, and you just take a string which contains some Python code. I define here a Python function, a very easy one. And in a later call, I just run this Python function from R. It just calls the Python environment with some input parameters which I took from R, as you can see here below. And then in the end, the answer is 42. So another thing I found very useful for when building Shiny apps. So Shiny is, I would say, in my experience, it's useful for generating small proof of concept things which serve as a report. So if you want to make an internal dashboard or want to visualize something interactively, this is very useful. And also if you want to share like simple interactivity with someone who's not a programmer, then debugging this might be sometimes a little bit not so straightforward, but with this React log, you can like visually represent very easily what actually takes place in your app, which makes it much easier. Also, sometimes when you have encountered an error during developing with this Shiny, sometimes the logs are actually not stored because the app thought that the program completed without error. And in this case, adding a custom Shiny server config to the Docker file helps out in that. And also play around with the init and idle timeout times. This can be, during development, something which is very useful. And then in the end, if you want to set up this as a web service, the Plumber package is very easy to use from R, because it just lets you decorate your code in a similar fashion as Roxygen, the documentation package, but with a different handle, and then you can just call it as a web service. So this is also very nice to integrate it into some mid-sized data volume processes. The focus here is always on getting the different elements working together and the different people working together, as we don't have big data and need to efficiently run everything, but we want still to have a quality answer at the end. So for this, this whole setup has proven to be acceptable. Yes, and then now to come to an end, we are using Apache Airflow, or starting to using it more and more, because it has proven also to be very facilitative in migrating small bits of these jobs and requests. And if anyone hasn't yet done this, it's even for smaller projects very useful to just integrate it into your workflow. Yara as a whole is now starting a new initiative to really characterize a crop and really simulate the whole crop, from the seed to forming the roots and keeping track of the whole weather conditions and everything. And this is actually starting, so if you want to, or if you're interested in this and so on, you should come talk to us. So this was a rather short talk, but I hope you still found it somewhat interesting. Thank you.